Dude, that is such a fake.
Okay, there's too much talking. Libby, do you know where you went wrong, or would you like to see it?
Number 3 was yes, right?
Number 3 should have been yes, and number 4 should have been yes. Liv, talk to me.
Yes.
Do you need to see it? Or you figured it out?
No, I didn't figure it out.
Okay, so let's look at number 4. We have...
Sure.
Mr. Evie, is that you?
Yes, I told Will to be quiet
Stop.
in a polite manner.
Haven't gotten here yet. I'm done. I understand you guys have been sitting and you've been quiet and you think it's unfair that you can't talk and all. I get it. I get it. We totally understand. But you can't be rude. We have to get this done. We have 29 days. All right, let's plug in. Both of them are -4. So 2 times -4 plus -4, does it equal -12? -8 plus -4 equals -12. -12 equals -12. So that works out. Okay? -4 minus -4, does it equal 0? Well, the opposite of opposite 4 is plus a positive 4. So -4 plus 4 equals 0. So that checks out.
Oh, I did -4 minus 4.
Gotcha. You okay there?
Yeah.
All right. Are we okay?
Yeah.
So what we're going to be doing today is a little bit of both. I want to start with where we left off yesterday. Chris, go ahead and give me the equations that I gave you to graph for homework.
The first one was 6x plus 3y equals 8.
So this was your homework that you needed to graph last night. 6x plus 3y equals 18. And 2x plus y equals 6. And let's discuss. I'm going to do mine in 2 different colors. I'm going to find my x-intercept, find my y-intercept, and graph. Ready? So, when x equals 0, what does y equal?
6.
6. Take the pen, ruler. When y equals 0, what does x equal?
3.
3. So let's graph this line. Over 0 up 6. Over 3 up 0. I still don't have my protractor.
Where is it?
Somebody borrowed it and I just didn't have time to get it. Okay, so we've got that. Did you get that on your homework last night?
Yes.
If you didn't, you're doing it right now. Stop doodling in your notebooks. All right. Second one, x, y, 0, 0. When x equals 0, what does y equal?
6.
When y equals 0, what does x equal?
3.
Okay, stop. Don't talk. Just think inside your head for a minute. What looks familiar here? Just think, don't talk. It's almost a rhetorical question. I want you to make an observation. What's going on here? Zoe?
It has the same solution.
They have the same numbers. So if I draw this orange line in, my intercepts are the same, and wouldn't my lines kind of just lay on top of each other?
Yeah.
Yes.
So, if my lines are laying on top of each other, how many common solutions are they going to have?
Every common solution.
Okay, so how many? So, watch. These are the same line. Therefore, they have an infinite, that's the word, that's the symbol for infinite, amount of solutions. An infinite amount of solutions. Every single point along the line is going to be true for every single other point along the line for both equations.
Only had to use
No, you were drawing it just now. I watched you. You were the one that I was talking to when I said stop doodling in your notebooks. But good try lying to me. Okay.
Dude, nice.
Good try. So, I'd like for you to open up your book to page 326. You can just have one open at each table. 326. Doesn't take any conversation on your part. Okay. We did the 1 through 4 in the class exercises for homework last night. Let's talk about 5, 6, and 7. Let's think. Take
What
notes.
is CW?
Yeah, sorry. We can call this, yes, CW. We're just gonna think out loud. 110, 210. We are finding objective. Find solution to a system of equations. Remember, we defined a system of equations as 2 equations together. So we're trying to find which numbers make both statements true. We started that yesterday. So, carrying on from yesterday. So we're on the class exercises 5, 6, and 7 on page 326. Let's read it. Number 5. We're just going to think about it. We don't really have to write anything down. We're going to write plenty down in a minute. A system of 2 linear equations has no solution. What does their graph look like? So let's reword. Can someone reword this in your own words to not sound as confusing as the book makes it sound right here? What is it? What, Mike?
Wait, could you re-say it?
It's number 5 in your book, right there. Okay, reread it to yourself, please. You're looking at the definition of system of equations. Linear. Okay, what does linear mean? Straight lines. Just straight lines.
They're not going to touch each other.
Okay, what do we know about 2 lines that are not going to touch each other?
Ooh.
Kara?
They're parallel.
They're going to be parallel. So if these 2 lines don't touch each other, can they have a solution?
No.
No. So they have to be parallel. They have 0 solutions. No solutions. You good there?
Yes.
Make sense? All right. The coordinates -3, so I'm on number 6. The coordinates -3, -1, 0, 0, and 3, 1 are solutions of a system of 2 linear equations. What does the graph of this system look like? So it's very confusingly worried.
Wait, is number 5 parallel?
Number 5 is parallel. Yeah. If there's no solution, they have to be parallel. Does that make sense? They're never going to intersect. All right. Okay, let's think about this one. Let's think about this example we just did on the board over here. Ready? If there's more than one solution, okay, take your ruler. This could be a bad thing. Take your ruler with your partner's ruler. Try, without breaking the ruler, to make it cross with your partner's ruler more than 1 time.
Let's go, Steven. Let's do this.
I got this, Kevin.
1, 2.
I got this.
Why am I always alone?
Oh wait, does anyone have a flexi ruler?
No, you can't break it. Can't bend it.
My guy's flexi ruler.
These are lines. They're linear. They're straight.
Steven, you failed me.
All right. So stop.
Put it down, Sandra.
Yeah, now it's curved. It's not a line. All right. So listen. Look at my face. Look at me. Stop playing with the rulers. Stop playing with the rulers. Put the rulers down. Could you make those rulers intersect in more than one location?
No.
Okay, unless you bent it. Okay,
Why
stop.
can't you make it?
There's no way. If you have 2 straight lines, there's no way you can make these 2 straight lines intersect in more than one location without bending it. And then it's not a line. Then it's something else. We call it a parabola. Okay? Or a cubic. It's something else. Okay? So, if they intersect in 3 places, what do you know is going to have to be true about those 2 lines?
No matter what equation that you have, they'll always be the same.
Yeah, they would be the same line. Look here. It's worded funny in your book, but there are 3 different solutions. If there's more than one solution for a system, then it means there's the same line. Does that make sense?
What?
So, this one, it says these 3 are solutions. Look at number 6. It says there's 3 solutions. It doesn't say those are the only ones. It just says those are 3. Okay? Make sense?
Mm-hmm.
It says, what does the graph look like? They would have to be the same line because they intersect in more than one location.
It says solutions.
Solutions.
Of
Yeah.
2.
Yeah. So there are going to be a lot of solutions. They give us 3 of the solutions, which means they have to be the same line. Okay? Okay, number 7. The graph of 2 equations appear to intersect at -4, 5. How can you check to see whether -4, 5 satisfies the system?
By putting those 2 numbers in the place of x and y in the equation.
Absolutely. Best one. Who can repeat what she just said?
Plug in the
I got
numbers
this.
and solve the solution and see if it makes sense.
Oh.
See if it-
I got this.
No, not really. No, Zoe said it perfectly. Mike?
A system of solutions cannot intersect at a cross points solution.
Zoe's going to say what she said one more time and we're all going to listen. Thanks, Zoe.
Plug the numbers that are given into x and y, which is in the equation, and you can see if it satisfies the system.
Yeah. If it makes a true statement.
Satisfied.
Satisfied. It makes a true statement if it makes it true. Okay? So you would just plug those numbers into the equations, and if it makes true statements in both equations, they're going to be true. So then it's going to satisfy both. Does that make sense, Mr. Boylston and Mr. Field?
Yeah.
Wait, what equation?
Yo, satisfy the system, dog.
It doesn't say any. It just says this point. How could I? They appear to intersect at this point. How could I make sure? I'm going to check my answer. Okay. I don't want a giant rush back at my desk because I'm not really sure what could spill. Everybody needs a whiteboard.
Kevin, I want this.
And a marker.
Yo,
You
Mike,
have
grab me one,
30
dog.
seconds to organize this. Go.
Mike, grab me a marker, dog.
Kevin, I get the best colors.
I don't want you to talk while you're doing this. I want you to do it rather efficiently.
Sam, grab me a board.
Do you stand?
Joe, grab me a board, whatever. Someone grab me a board.
I'll get it. No, I got it.
Yo, Chris, I got you a battery, girl.
I don't want no battery.
Right with the outline.
I don't take out mine. I don't take yours off. Yeah, give me that. This is horrible.
I'm not using that. Kevin, you got it.
Oh, it's actually pretty good.
I got the worst colors.
You want it.
And you give me the worst board.
This is right. Or you just do the back.
Okay. Listen to me. You have 8, 7, 6, 5, 4. You're done talking. We need to be on the side with the graph. On the side with the graph.
What?
I'm done listening to you talk. Okay. In your book, I need you to open up to page 326.
There's like
326.
3.26.
all, you're just going to draw in your y-axis and your x-axis to make your origin, okay? Okay. I am going to assign you a problem on your whiteboard. You are going to graph it. If it has one solution, I want you to write the ordered pair of the solution. If it has infinitely many solutions, I want you to show me that on the graph. If it has no solution, I want you to tell me about the line. Okay, I want everybody to right now graph number 1, written exercises on 326. Go. It doesn't take any talking. If there is an intersection, I want you to write me the point of intersection.
So do you just fill in 0 for like one of them?
Yeah, you just do your x and y intercepts. I want you to graph it, and if you find an intersection point, I want you to use a ruler to draw your lines in. You need to make an x and a y axis on your board.
How can you have y and x both as 0?
Right in the middle.
Then where does your line go?
No.
X is 6 and Y is 2.
Okay, excuse me. Let's practice this really quick. Number 1. Let's get back in the saddle here, people. We have 2 equations. We have x plus y equals 6 and x minus y equals 0. You have two intercepts, your x and your y. Watch me right now. I'm going to do this. Watch, and then I'm going to give you another one to do because we forgot how to do this. Stop talking. 0 and 0. When x is 0, what does y equal? 6. When y is 0, what does x equal? 6. Okay, careful. When x is 0, what does y equal?
0.
When
0.
no,
Zero.
sorry.
Yeah.
Yeah.
Libby.
Why?
What?
What?
I'm trying to figure this out. Starburst. This is negative.
Don't
Should be 1 and 1.
Can it just equal 0 because if it x minus 0 equals 0.
Well, I'm trying to
and
figure out
negative
how to-
1 goes
hang on.
into 0.
Stop, please. Stop, please. This isn't good because this only has 1. So this one is bad one. Is the camera on this one? On this?
I got it.
Don't watch,
Are
kids.
you-
Don't
Are
watch.
you supposed to get this in 0?
Hang on. Wait a second. Wait a second. This was hard to graph because you don't know how to graph this line. I'm done with the talking. I'm done. I will blow up. I'm done. My patience is over. Okay? This is this line. You don't really know how to graph it, so I'll give you this line. Okay? And then we add what? 6 and 6. So where do these two lines appear to intersect?
They appear at
3, 3.
I need you to talk like a normal person.
3, 4, and 3.
We're fine. Which one?
They appear to intersect at 3, 3. Okay? They appear to intersect at 3, 3. I want you to test this intersection point, this solution for both of these. Do it now.
They work.
Yes, they both work.
Yep.
3
Yep.
plus 3 equals 6.
Yep.
3 minus 6 equals 0. Yes.
Sam? Good job. Stop. About to lose it. Okay, Sorry you didn't know how to graph that one. Number 4 is going to have that same issue. The other one should be okay. Yeah. All right. What? So, does 3, 3 work?
Yes.
Okay. I'd like for you to do number 3. Graph both of those, please.
So much.
Okay, so what's up with that? Why?
Because
Write
they
it
don't.
on your board. Okay, so what? So what about their solution? Why? What kind of lines are they?
Parallel, wait.
You can go on number 5.
Jump is here, right?
Alright.
Yeah. No.
Mike? Yes, Samantha. Yes, so what about their solutions, Libby? Like, are we gonna say these again? Would be negative. So if x is 0, y would be negative 5. Okay, so do they have a solution?
No.
So do they have a solution?
No.
That's what you need to write.
No solution.
Because
What next one?
because why? Yes. They're never going to intersect. Uh-huh. Okay, you can go on to number 5 after you've done number 3 and had it checked. You need to write a statement about their solutions. Yes.
That's missed.
That's okay, but okay. So they're parallel, so what? There's no solution. No, don't write no intersection. There's no solution because you're looking for solutions. So Mike, if I plug in 0 for x, I'm going to get -2 for y.
For here.
No.
Oh, wait.
Yeah. So that's why your line is looking for me.
This is number 5.
Okay? Okay. What was that one?
Number 5.
Yes.
Can I go to what number do we go on?
Odds. So 7.
Okay.
Is this wrong?
So tell me about their solutions. Yes. I want to know about their solutions. What about their solutions? I know they're parallel, Mike, but so tell me about how their solution. Yes. Yes.
Should I draw? I don't know how to draw.
You just draw one.
What number should we go on next?
7. Yes. Right. And so, what do you know about their solutions? Infinite amount of solutions. Yes. They have the same solutions.
Or different,
They don't have any solution.
but they're parallel.
Right, Mike. But look, are they ever going to cross?
No.
No. So the point that they cross is the solution. So they have no solution. Make sense? Okay. Now that you guys are in different places, I would like for you to write the number that you're doing on your board, because I'm not really sure who's got what.
That says intersect.
What is that, number 7?
Yeah, it's number 7.
7. Oh, you know what? Number 7, you got your X's and Y's mixed up. Be very, go back and do that one more time.
If you were trying to find x, then that would be
Samantha.
yeah, no. So x is
Try one more time.
no, it all depends on negative.
Okay, try graph this one more time. Your graphs look beautiful.
Positive side.
Yeah. So what do you know about?
It'll never
Yeah,
cross.
Well,
Actually, they do
negative
lay on
3
top of each other in line.
y.
So, but it's infinite. Every point they have in common. Yes.
What are you doing?
Number is that, Kara? Kara, my dearest,
So it's supposed to be.
Carrie, you're.
check out where your X's and Y's are in that second equation because they kind of mix it up.
It should be.
What are we doing
both
for 7?
equations should be
9.
the same. What? You should look at it.
What number is that left?
5.
Okay.
They're both the same.
They don't though. Why? I didn't want you to do number 4.
Oh.
Number 4 is you're doing it odd.
So it would be y equals 3. Just substitute
Okay.
find x. That's what you're doing. Solutions.
Alright, I need your attention on number 7.
Guess you're right.
Okay, 1. You gotta be really careful. Okay, here. If x equals 0, what does y equal?
4.
How about
Wait,
negative 4? If y equals 0, what does x equal?
8.
8. Look here, really careful. This is where you guys are getting mixed up. If x equals 0, what does y equal? 2. If y equals 0, what does x equal?
Negative 4.
Negative 4.
Because it's a negative.
Oh, yeah.
Okay? So, did we do that right?
Yeah.
I didn't do it.
You didn't do it?
I didn't do it yet.
Oh, okay. Everybody's kind of getting this one all mixed up. So 0, negative 4, and 8, 0. 0, 2, and negative
4. Negative 4. It's negative.
4.
Parallel.
These are going to be parallel. On number 7.
No chance.
Let me tell you where the mix-up occurred so that you can be wise in times to come. That's so totally not how you graph this. I'm getting kind of worried, actually. It's not that funny. Okay, watch, please. Listen. Look at me. Look. This is where you guys got mixed up. The y and the x are in locations that are a little bit different than they have been in the last 4 problems. You got to be really careful here. Okay, you gotta make sure you don't have these mixed up. These are parallel. Parallel lines have no solution. Okay, keep going. Go on to number 9.
But why would it be -4 on the second one?
Where? On the
Because
second one?
Yeah.
When y equals 0 because it's negative x?
Oh, okay. I
Makes
thought that
sense.
was minus.
Sorry. 9? Yes, yes. What number is that?
5.
So what's their one solution?
That's what I wrote.
I know, you have to give me the.
Do you go on past number 9?
Yeah, you can go on to 11. Actually, number. That's fine. Yes.
Do I go on number 11?
It should be +6. Yeah, you have on your graph +6, but you wrote -6 in your answer.
Oh,
This one would be negative.
Joe,
Yeah.
arrow me.
So this is equals 0.
You don't say that.
Good job, Kara. Good job.
That's
Okay. I need you to get through number 9. Once you have gotten through number 9, you can do number 11. And after you finish number 11, I want you to write your homework down. Okay, where do they intersect with each other?
0, 6.
What number is that, Kevin?
9.
They do intersect, but that's not it. I look for you to graph those again. Good job, Lee. What number is that? 9.
How do you get -2 there?
This is right.
Oh, you didn't.
You should have gone over 0 up 6 again. You went over 6 up 0 for that second line, the third. So right there. Okay, you're good. You have it. Yes.
Swine.
Yes.
Yes. Arrow me, Joe.
Okay.
Commissioner, we need different graphs for the homework, right?
Yes. Okay, listen to me. Let me verbally tell you how you're going to do your homework. Okay? I want you to erase your boards, please. Yeah. That's fine. You can, yeah, you can put it back like that.
So is that our homework now?
That is your homework. Each system needs its own coordinate axis, coordinate plane. Do not draw one set of axes and put a million graphs on there.
So like, the axis.
X, Y, each, you're gonna need 6 graphs. Okay?
Do they have to be,
No, they don't have to be 10 by 10. They just have to fit the line on there.
okay, so how?
So if you find your point and then you're like, oh, well, I don't need 10 by 10 because my y and my x-intercepts are at like, there's only 6.
Wait,
And I want you to use a ruler. I will be checking your graphs. If not, I'll keep you in at lunch and you'll be redoing the graphs.
Is it the same thing we did on the whiteboards? I'm serving, so.
Okay, go. Anybody else serving? All right.